Okay, from the book. So if you have the same book that we um, put on the syllabus, if it's the same edition, we should be looking at the 12th edition of Vector Mechanics for Engineers. If it's not the same edition, it's going to have the same content, but the problems might be different and the exercises might be different. So it's not a big deal, it's not a problem. We can work around that if you didn't get the right version, but hopefully you did. And if you go to chapter 2, um, and it's going to be statics of a particle. That's where we're trying to head to. So this week we're gonna finish with all the content that we need in terms of vectors, so that we are ready to start analyzing systems of um, equilibrium. So in section 2.2 we have addition of planar forces. We already know how to add and subtract vectors. In a few days we're gonna learn how to multiply vectors. It's not, we have two options, the dot product and the curl. So make sure you are aware of how to differentiate those. We'll talk about those properties later, but just go ahead and remember that when you have a vector, the direction of the vector matters and the magnitude also matters. So the magnitude here in the right hand side is 10, but the direction is negative because it's going towards the um, left hand side of the screen. So also make sure that you realize that there are two important concepts that we have to analyze, which are, the first concept is the concept of direction, which we know. So let's say we have the origin, this is trivial, we should know this by now. So in this section we have a negative force in the x direction and a positive force in the y direction. This quadrant will tell us that the force is negative x direction and negative in the y direction. So this is for the coordinates, this is for the components, but this is for the components, fx and fy. If the components are negative with respect to the coordinate system, then you just carry the minus. But the magnitude of the force, there's a concept that we haven't mentioned, which is, say you have a column, okay? If you put a force on it, this is called a compression force, and it's a negative force. So the magnitude of the force is negative. If it's a stretching force, meaning that you have the same column and then you pull it with a crane or something, you try to lift it, this force is positive because it's stretching. Okay, this is a stretch, this is pulling, or better, is pulling. Instead of stretching, let's say pull. It's pulling. So this is a positive force. In this case, it got to be negative with the coordinate system too. So you have x and y, so it's negative coordinates. But let's say you have this. This force is like that. So the direction of this force, and say this is x and y. the direction of this force is positive, but is compressing the system. So when we analyze the system, this will be a negative force. Okay, we'll talk about that later. For now, I just want to differentiate that you can have stretching and pulling, and the vector could have, the vector itself is with respect to the coordinate system. Later, when we talk about the system, then we have to, this is the whole system. Then we have to analyze if the system is carrying positive or negative forces. Positive forces will be pulling, negative forces will be compressing or, compressing or stressing in a compression fashion. So in this case, this is a single vector, so it's negative because it's going in the negative hand side of the, or left hand side of the screen. Okay. Next, we talked about the result of adding forces, how we can just have two forces with the same magnitude in opposite direction. These two forces will cancel out, so that will make the system rest at 0. Addition of vectors, please go over this chapter and look at the videos that we've made already, the lectures about how to add the vectors. We have examples about this, and obviously there's the same laws of math for numbers applied to vectors. Commutative law will say that p plus q is the same thing as q plus p. So you decide which one you put first and which one you add later. This is the blue vector is the resultant of p plus q, which obviously if you form the system means that both of them will be the same thing. That's why you add the resultant in the middle. Okay, this is just more examples that you would be able to add and subtract vectors by components or by the sine law. So in this case, q is negative because of the direction, so you simply have to subtract. So p minus q, or p plus q, depending on the direction. In this case, p and q form this resultant, and p plus q plus s is the origin of the vectors and the endpoint. So PQS could be the curvature of a shuttle, for instance. So this vector goes from 0 to point A to the end of P, could be the first trajectory or trajectory. The end of P is the beginning of Q, so the second trajectory. And so this is very useful in dynamics. But in statics, you can just add the vectors the same way. But this usually represents curvature. And you remember the change in direction could cause a force. So that's how you represent the force because of change of direction. All right, so obviously P, Q, and S will be able to add up, but also Q and S by themselves, you can find them, what the relative force between them. We should by now understand this pretty well. If you still have questions, you contact me. We need to talk about it further. We can set up an appointment and talk about those things. So we should be able to compute several forces by now, right? So R, the resultant, is going to be the force, the total force of these three vectors combined. And notice that it's always, the total force always with respect to the origin. So these total force R, or sometimes capital T, sometimes capital F, is similar to when, if you took circuits, you had to create total resistance when you had a bunch of resistors in series or in parallel. And the total resistance is the combined resistance of all of them. And if it's in series, you add up. If it's in parallel, you did 1 over, etc. If you remember that term is the same concept. If you haven't seen that, then don't worry about it. It's just the concept of you add the vectors together and then you can find the resultant force. If you don't have a way of putting them together, Then you, instead of they're giving you the coordinate system and the directions and the angles, then you find the components. And at the end, you do square root of the components x and y and z if you have 3 dimensions, and that's the total force. So we know how to do this by now. We form the closed geometry and we find the total force. This case is capital F. Same here, P and Q. Find the total force by closing the geometry. P and Q, same thing. So go through your book and look at the examples. So let's see, let's get this. Let's get this example. Okay, so all right, they're telling us that we should draw the scale. Well, it's gonna be tough, but let's just draw the parallelogram with these two vectors P and Q and measure the magnitude. So we should be able to put them together from point A. We have one that is P, and we have another one that is Q. So actually I don't have enough room there, so let's do it over here again. So P and Q. So remember, we copy paste. This one will copy here, P, and this one will be here, Q. They're the same. Okay, and the resultant is that goes through the middle. Let me choose a different color. The resultant is this. All right, and they're telling us that between here and here, there's 25 degrees, and all this is 90, and this is 20. So we have that if all that is 90, we have, what is this angle right here? Let's call that, I don't know, theta. And theta is basically the angle between Q. This is what I'm calling theta, because we don't know that angle. We know this one, that one, but we don't know that one. And all this is 90. So 90 equals theta plus 20 plus 25. That means that theta equals 90 minus 20, 25 minus 45 equals theta equals 45 degrees. Okay, so this is 45 degrees. All right, so why is that particularly useful? Because we know that this is 25 and this is 25. But also we need to know this one right here. So all those four angles are gonna have to give us a 360 degrees. So 360 equals, so that's theta. Let's call this, I don't know, beta. Beta is this angle between here and here. Okay, that's beta. Okay, I wish I could do it a little better. That angle right there, that's beta. So beta plus these two are the same, and those two are the same. So 25 plus 25 is 45 plus 2 beta. Okay, so 360 minus 45 divided by 2 equals beta. And 360 minus 45 is 315 divided by 2 equals beta. So let's do a calculator. 360 minus 25 times 2. Oh, this is not 45, it's 50. 25 plus times 2 is 50. So it's 310 equals divided by 2, 155. Okay, so first of all, this is 25 plus 25. 25 is, times 2 is not 45, is 50. I apologize. So this is 50, 50. And we said the beta was 155. Okay, so this is 155 and this is 155. Okay, so with that we can do sine law because we need to do f total. And if you remember, we have a video about that, so we should just be able to go ahead and look at the video. Square root of both sides, so it's 60 squared plus squared 60 newtons squared plus 40 squared minus 2 times 60 times 40 times cosine of the up angle, which is 155. All right, let's just double check that I have the formula correct. Okay, so 155. Okay, so 40 squared, 50. Yes. Okay, so r squared. So basically, this is square root of all of that. And if you put that in the calculator, which you should try and use this in the calculator, type it in. Remember to always use degrees and not radians. We have 97.7. So basically, we can do 98 newtons. So the resultant base force is 98 newtons. Okay, that should be it. All right, very well. They're asking something else because I see that they're doing angles here. They're asking about theta. And where is theta? I mean, not theta, alpha. Alpha 35. Oh, that is alpha. Okay, sure. So they want us to use alpha as 35. Well, that's okay. That's all good. What exactly are they trying to do here? So sine of A divided by Q is 60, and sine of B, where is B? 155 divided by R, which is 98, times sine of A 60 equals, okay. They're doing sines and sine law for what? To determine the resultant. Okay, well, that's awfully complicated. If we already have 20, we have the, oh, I guess, let me see something here. Is it because, oh, I see. Okay, so this is because we don't exactly know what is the angle between the resultant and P, which that's a good point. Yeah, we don't know what is the angle between the resultant and P. But I don't know why they're making it so complicated. If what they want to know is that angle right there, which we can call angle small lowercase a. It's not a lowercase a. Lowercase a in degrees. This is the total force. I called F, they call R. Okay, so if you want to find that angle, I'm not quite sure why they're making it so complicated. All you need to do is draw your triangle one more time, and then express what you know. That angle is 155. We don't know that angle, which we're saying A. We do know that this is P, which is 40 newtons, and this is 60 newtons. I'm exaggerating the, oh, I'm exaggerating the um, triangle here. This is actually not as steep. This is more, this has less of an angle here. But anyway, this is Q, and this is R, and R equals 98 newtons. So remember, the sine law says that R divided by sine of 155 degrees is the same as 60 divided by sine of A. Okay, and then all you have to do is solve for R. No, not for R, we already have R. All we have to do is solve for A. So yeah, so basically we have to do is sine A is equal to 60 times sine 155 divided by 98 newtons. And this is sine A. So A is equal to sine inverse of 90 divided by 68. .32 times sine of 115. All right, so for this we can go to a calculator. So sine of 155 degrees, yep, 0.42. Okay, times 0.42. All right, so actually we can do the whole thing here, I guess. 60 divided by 98 times 0.258. Let's say A equals sine inverse 0.26 because it's 25.8. All right. So let me see if I remember how to do sine inverse here. So let's see. I guess it would be sine hat minus 1. Yep. Of 0.20, what was it? 26. 15.07. Is that correct? 15.07. Yeah, 15.04. There you go. So 15 degrees. Okay. And by the way, this is a pretty good tool to use. Is wolframalpha.com, and it's free to do all these computations right here. Of course, you can actually create an account and do much more advanced coding and operations, and you need to pay, I don't know how much per month, but the free version is pretty good for things that we're going to do in this class. and they actually are the creators of something called Mathematica, which is a programming language that is very useful because it is based on actual variables. So Mathematica, let's see if we can use, we can show you what you can do. Yeah, so some things like that. So you can actually program code based on variables. You don't have to input names like numbers or actual numbers like a calculator. We can leave everything in terms of variables. Okay, so wolframalpha.com will definitely help you compute um, a lot of your operations for this class if you don't have a calculator, which I hope you do. All right, so we computed the angle using the sine law. We already did this just to remember how to do it. But I was hoping to go through more concepts on your book. So this is a good example right here. So it's a boat, and actually this is for like garbage or carry things on through a river, and they're giving two boats. We know that one is 30 degrees from the horizontal axis. The other one, they're asking us to find out what it is. Actually, they give it right here. It's 45 degrees. And they're saying that if the resultant is 5,000 pound force, then they're asking us for the force on through each vector, through each rope. All right. And there's another question. The value of alpha for which the tension in rope 2 is a minimum. Okay, so this type of question is actually pretty interesting because we have to minimize the value of alpha. So we already know how to do this part. You should be able to create a geometry where you move vector 2 to point A and move vector 1 to point C. And when you close it, it will be a resultant right there. Okay, so let's see, they actually try to solve it. Yeah, there you go. So you know the angles and you know the resultant. So in this case, it's pretty easy because you just have to use the sine law where they're asking us if you know 30 and you know 45, then this half triangle is 180 because the whole thing is 360. 30 plus 45 plus this angle, let's say theta, is 180. Okay, so 30 and 45 is 75. 180 minus 75 will give us this top angle. And then we can do sine law between 5,000 divided by sine of theta and use any other forces. Say T1 with respect to sine of 45. T1 was, oh, well, we don't know. That's what we have to do. It's right here. And so we do that twice, one for sine of 45 and one for 30, I guess. I already know that I'm talking too much, so let's just go ahead and try to do it. Let's go ahead and pull the example one more time. So, okay, let's try and do this example. Move over here. All right, so they're saying that part A, alpha equals 45 degrees. All right, so in that case, it's pretty simple because if we have point B and we have, let's say, force 1 or tension 1, point A, and then from point B to point C, we have tension 2. So all we have to do is move T2 over here. Okay, hopefully that's good. And T1 over here. That's supposed to be parallel. So, whoops. Okay, let's try to assume that's parallel. Okay, so the total force R is going to be that line between those two. And they're telling us that this is 30 degrees and this is 45. So this is 45. If you remember trigonometry. So 45. All right, so let's say this is theta. So 180 degrees equals theta plus 30 plus 45. Then theta equals 180 minus 75. Okay, so let's go back to Wolfram alpha. And we do 180 minus 30 minus 45 is 105. Theta is 105 degrees. Okay, so we have everything to compute T1 and T2. Because remember, this is T2 right here. So R, which is 5,000, divided by sine of 105 degrees is equal to T1 divided by sine, the opposite is 45 degrees. And let's move this a little bit. There we go. And R, which is 5,000, is equal to sine of 105 degrees, which is equal to T2 sine of 30. All right, so we're trying to find T1. Therefore, T1 is equal to 5,000 times sine 45 divided by sine of 105. Okay, let's do that. So 5,000 times sine 45 divided by sine 105. 3616 pound force. So this is equal to 3660 pounds. All right, and this one is T2 equals 5,000 times sine 60 over, sorry, 30, sine 30 over sine 105. All right, sine 60, no, sine 30, not 60, 30. 2588. So this is 30. This is 2588 pounds. Okay, so if we look at the book, they should be getting something very similar. If not, we did something wrong. Yeah, 3660 and 25. Okay, cool. Now, they're asking us for the value 2590. What did we get? 2588. Yeah, good. Okay, now for part B. So this is 2588 I got, and 3660, they're approximating further, so we're good. Value of alpha for minimum T2. So this is going to be an interesting point because they're asking us to, at what point, so the question is this. Let's see if we understand the question. They're asking us if, let's say they want to save gas or something for boat B, or for boat carrying point C, I mean, because B is the common point. So let's try it again. So this boat is going to be pulling at that whatever force is doing, and they're asking us, hopefully you can visualize it. Let me try to help and see what they mean. So this boat has multiple possibilities, right? From being all the way here at 0 and being all the way here at 90. So obviously, if you're here in 90, it will not help because you're going to be pulling that way. And what you want to do is pull that way. So that is not going to work. But maybe at 80, it could work. We just now want to know what is that force at cosine 80. So for instance, if you do, I mean, you can do iterations. Like you can use a computer and say, okay, if this is 5,000 and this is T1, and this is 30, this is 30 degrees. Obviously, T1 is going to be different too, depending on what happens with alpha, right? And then we have alpha, and then we have T2. Okay, so we have to find the minimum value of alpha. Is it 0? Well, probably not. If it's 90, probably not. We have to find the minimum value of alpha that will help find the minimum force. So part B is actually the value of alpha, which minimizes the rope 2. Oh, my bad. So it's not the minimum value of alpha, it's the angle at which the force is the minimum. So what is the force at 2 that is a minimum given the value of alpha? And they're basically drawing the same drawing here. Which one is the value of 2 that we need to know? So we have to keep 30 fixed because the boat can only go at 30. But the force will change because the angles will change. So we don't know T1, we don't know T2, and we don't know alpha. So let's see what we know. We know the resultant has to be 5,000 because that's the amount of force that it needs to pull to keep the velocity that they want, for instance. That right here will be the first thing that we have to assume. So if we say 90 here, this is going to be 30 and this is going to be 60. Okay? So if we have 60, that will give us a solution that we can compute with alpha equals 60. So if you notice, the minimum amount of force that we can have is when T1 and T2 have value of 90 degrees. What does that mean? That means that the minimum force at T2, let's go back here. The minimum force at T2 is when T1 and T2 form a 90-degree angle. So that is basically the minimum amount of force that you can have when T1 and T2 form 90 degrees. So if you draw that, we have that these two, well, but not right there. Let me try to draw it again. So I drew the point. So this is T1, and this is T2. There we go. So this point right here, 90 degrees. That is the minimum angle that we would need, because that means that if you draw your resultant force, which is 5,000 pounds, you would have T1 here, T1 here at point C, and T2 there, and T2 there. So that means that this is 60 and this is 30. And that is a 30, 60, 90 degree angle. And the reason is because we cannot change the degrees of 30. I mean, we could, if they gave us the option to change this, we would have made a 45 and 45, would have made a 90, 90, 90 everywhere. So 90 here, and we would have made much easier triangle, because 90 times 4 is 360. So if they ask us what is the minimum degree angle that we can use for A and B, then it would have been 45 here and 45 here. Therefore 90, 90, 90, 90. But this one was fixed at 30. So that means that this has to be 60 and that has to be 30. So if we try and compute again, we'll have 5,000 90, 60, 30, T2, T1. So let's see what happens here. You're going to see it's 90 because when you do sine of 90, you're going to see what we get. So 5,000, well, so let's go to calculator first. If you do sine of 90, which is the same as cosine of 0, you get a 1. So what happens is, this is the same as cosine of 0. Okay, so sine of 90 means that that component carries the whole force. The maximum force goes through that component. Okay, in other words, if you visualize it, if you're trying to pull, let's say if you're trying to pull a wagon, like a train, it would be more efficient to go that way than to go that way, right? You can still move it, but here 100% of the force is being transferred to pulling the wagon, versus here you're going to start lifting it, and that is going to be more energy that you need. Okay, so here you're going to have more, is going to be the minimum. So the question is, the minimum amount of angle that you need to transfer the maximum amount of force is going to be 0. Okay, well, the component of Fy is 90 in this case. So they're asking us, what is the minimum angle that this could be? And in that case, the answer would be at, that would be a 60-degree angle. Okay, so that the force between T and T2 is 90 degrees. So computing those values, we have that 5,000 over sine of 90 is equal to, remember T1 and T2 now change, T1 over sine of 60 And 5,000 sine of 90 equals T2 sine of 30. So this is T1 equals 5,000 times sine of 60 over sine of 90. And this one is, remember, this is 1. And this is 5,000, I'm sorry, times sine 30 divided by sine 90, which this one is 1, equals T2. Okay, so 5,000 sine of 60, where's my calculator? Here. 5,000 times sine of 60. 5,000 times, what's going on here? 4330. So T1, 4330. And T2 equals sine 30. Calculator. 2,500. Okay, which that is what we get in the book.